Hello and welcome to Mysteries of Science. My name is Dan and I'm the editor of Science and Nature, the monthly magazine from the team behind The Week Junior.
And I'm Michael, the acting deputy editor. On this podcast, we investigate weird events, strange creatures, and mysterious places.
We're back for a brand new season of mysteries, and we're back with a bang.
Yes, so on the 28th of March 1949, so around 75 years ago, British astronomer Fred Hoyle was on a radio show, much like this one, and first used a term which many of you will be familiar with, the Big Bang.
I've definitely heard of that before. The Big Bang, I think, is how scientists believe our universe began. Is that right?
Yes, although even though he came up with the term the Big Bang, when Fred Hoyle used it, he was actually making fun of the theory. He didn't quite believe in it.
Oh, so the Big Bang is kind of like a joke term.
Yeah, he was like, oh, this Big Bang. He wasn't kind of using it maybe the way that we use it today.
I guess it's a bit of a strange theory that the universe began with a bang. So let's begin with a bang here. How do we know it happened?
Yes, how do we know it happened? What is it exactly, and what can it tell us about the nature of our universe?
I think we'd better go back to the beginning to get some answers.
This is Mysteries of Science.
So, Michael, the Big Bang. Big, weighty topic to start off this new season. Where do we start?
Well, we've got two expert guests with us to help us out, so why don't we say hello to our first?
Hello, my name is Dr. Maggie Lieu. I'm an astrophysicist at the University of Nottingham. And there I actually work on both cosmology and machine learning. So cosmology is about like the parameters that govern the universe that we live in. And it will tell us like everything from like all of its past to all of its future. And I study these things using machine learning techniques, so artificial intelligence, to help process the huge amounts of data that we have.
Welcome back to the show, Maggie. It's really great to have you back. She's a loyal friend of the podcast, and some of you may remember her from Your Mysteries special, where she answered a mind-bending question about what comes after space. So I've got another tricky question for you, Maggie. What is the Big Bang?
Yeah, great question. So even though we call it a Big Bang, actually nobody believes that it started off with a bang. We don't think that there was a sound at all. We think it was just a very rapid expansion of our universe. And it goes back to a guy called Hubble. So he was looking at Cepheid variables, which are variable stars that have a very unique kind of duration on its brightness. So how fast it pulsates is related to how far away it is, right? And so you can figure out how far away they are from its brightness. And he found that the ones that were further away from us were moving away from us much faster than the ones that were close by. And this tells us two things. It tells us that everything is moving away from each other, but the ones that are further away are moving even faster than the ones close by. And this allowed him to determine that our universe is expanding. So if you think that our universe is expanding, and it's expanding faster and faster over time, it must have started off at one point, right? So if you calculate backwards, where did these things start from? You reverse the time, and it turns out that everything must have started from an infinitely dense, infinitely small point in space and time. And so this is what we call the Big Bang today.
Okay, so there's a lot to unpack there, including the fact that the Big Bang wasn't necessarily a bang. I imagined it as a massive explosion, like the Death Star blowing up in Star Wars, but it sounds like it was more like a balloon expanding maybe, rather than a balloon being blown up, rather than something blowing up in a big boom.
And if I understand Maggie correctly, it seems that we sort of understand the Big Bang by working backwards. So we look out at the universe, we see that everything is moving away from us, everything is getting bigger. So we sort of rewind the tape, and we think, well then, if we go backwards in time, everything must have been closer and closer and closer and closer to each other until it was like in one tiny dot of space. Is that right?
There are other things that point to us having started at a single point in time. So I guess one of the things is the cosmic microwave background. So if the universe began infinitely dense at an infinitely small point, you would have expected it also to be infinitely hot at that point, right? But if the universe was infinitely hot or very hot in the early universe, then we would expect to see some remnant radiation of that. So this was what was predicted in theory. And then many years later, there was some, I wouldn't even call them physicists, but they were working at a company called Bell Labs. And they had this like giant antenna, and they were trying to look for signals, radio signals in the sky. And they just kept seeing this like residual amount of radiation that they kept picking up. And they thought it was noise, but they couldn't get rid of it no matter how much they tried. At one point, they even thought it was like pigeon poop, because there was loads of pigeons like roosting on top of their antenna. And so they were like scrubbing away, getting rid of this pigeon poo, but they still couldn't get rid of the signal. But then like a nearby physicist heard over the grapevine that these guys were detecting some very small signal. And then he knew straight away that was the cosmic microwave background that was predicted to be like a remnant radiation of the Big Bang. And this is like anywhere in the sky. So it doesn't matter where you point your radio antenna, you would receive this microwave radiation.
Maggie mentioned cosmic microwave background. So that is literally the leftover glow, the afterglow of the Big Bang. I've heard it called the afterglow of creation. I love these tiny details, and that's probably like the one thing I'll take away from this program today is like you're looking for the biggest, most important events in our universe, and you end up on your hands and knees scraping away the pigeon poo because it might be that's mucking up your readings on your telescope.
I know, it makes you wonder kind of what other huge discoveries right now could be being mistaken for an animal's poo. The secret always lies in the poo.
Well, as we said earlier, one person who thought the Big Bang was a whole pile of poo was this astronomer called Fred Hoyle. But why did he think that? Why did he think it was such a bad idea? Especially if we've got all this wonderful evidence that Maggie was talking about.
Well, Dan, why don't we say hello to our next guest?
Mm-hmm.
Hi, my name's Ethan Siegel. I'm a theoretical astrophysicist, and I'm a former professor of physics and astronomy. And over the last 9 years, I've become a full-time science communicator. I run the blog Starts With a Bang. I've authored 4 going on 5 books, and I'm really looking forward to speaking to you all today.
Welcome to the show, Ethan. Tell us, why did Fred Hoyle not believe in the Big Bang? This great theory that we think is how the universe started.
He was like, this is a creation myth. And he dismissed it as the idea, as ludicrous, that the universe could have begun with what he called derogatorily a Big Bang. And instead he said, look, elements that we have, carbon, nitrogen, oxygen, and the heavier elements, could not have been made in this early hot dense phase of the universe, even if it existed. These elements had to be made in stars. And so Fred Hoyle pretty much invented the science of what we now call stellar nucleosynthesis, where we talk about how light elements inside of stars fuse together to build up the heavier ones in the periodic table. And throughout the 1950s, Hoyle was convinced this is how the elements are made. And surprisingly, even though Hoyle was wrong about the Big Bang, he was right about the heavy elements. They are made in stars.
So Ethan mentioned something there, stellar nucleosynthesis, which is basically when small elements come together inside of stars to make bigger, heavier elements.
Yeah, that's how stars make their energy. So elements fuse together, releasing energy that we see as sunshine. So even though Hoyle was sort of wrong about the Big Bang, he was still right about something. And when he heard about this, sorry to refer to the pigeon poo all the time, but when he heard about this pigeon poo evidence that Maggie was talking about earlier, did that not just make him change his mind?
That was the smoking gun evidence that you could see. Oh yeah, that's the evidence for the Big Bang. That's the big piece of evidence. Hoyle was not convinced. Even after all of that, Fred Hoyle would not change his mind. He would give lectures all the way through to the 90s about how we live in a fog, and this fog of leftover glow is mysterious. Once Fred Hoyle died, everyone stopped working on his alternative ideas, because no matter what, no matter how famous you are, no matter how right you were about other things in the past, in science, who you are, how much clout you have, how much prestige you have, all of it is meaningless. All that matters is the evidence we get from the universe itself. And when it comes to that, the Big Bang has reigned supreme, now going on 60 years.
It's quite the message in science. All that matters is the evidence.
Yeah, exactly. And we're bringing the evidence today.
The pigeon poo.
Yes.
By the bucket load. Okay, so I have a question. So the Big Bang, we know that happened, but what came before the Big Bang then? What caused it? What did the universe look like before the Big Bang?
So this is where all the physics that we know of breaks down. Basically, no, like none of what we're familiar with can tell us what came before the Big Bang, right? Because our typical mathematical tools just don't work on those scales. But there are loads of theories that are not proven and can't really be proven, I guess. So this also kind of comes down to cosmology and these parameters that will determine what our universe kind of progresses to be like.
You had to ask that question, didn't you? You had to go one step further.
Always take it one step too far.
Exactly. Well, we're here now. So, what are these theories of what happened before the Big Bang?
You know, the biggest thing I'd say we haven't touched on is the Big Bang is a story of our cosmic origins. And for a long time, people wondered other end of that was going to be, what the cosmic fate of the universe was going to be. Because you can imagine that the universe is a race between gravitation, which works to pull everything back together, and the initial expansion that works to drive everything apart. If the universe is a race, then the Big Bang is the starting gun to that race. And who's going to win? Early on, scientists imagined three possibilities. And again, these three possibilities go all the way back to the 1920s. You can say, well, let's imagine a universe where you have a race and it starts expanding and gravity works to start pulling everything back together. And maybe gravity wins. Maybe it expands, but gravity pulls everything back together, so the expansion reaches a maximum size and turns around and starts contracting, and then whoosh, everything ends in a big crunch, a reverse of the Big Bang.
Blimey, that doesn't sound too good for everybody. So that's a potential end of our universe. Tell me, Ethan, is there any other?
There's got to be another way.
Yes, exactly. Could I choose option B?
Then people said, well, imagine that it's the other way. Gravity doesn't win, the expansion does. That things expand, and gravity tries to pull it back together but can't, and it keeps expanding forever. So the universe just dies a freezing death. Everything expands away from each other and it can't pull itself back together, and that's the ultimate end. Or you can imagine not that the porridge is too hot and not that the porridge is too cold, but just like Goldilocks, it's just right. Imagine that they're perfectly balanced, that gravitation works to pull things back together, but the expansion keeps going.
That sounds a lot better, the Goldilocks theory, I think. I'd much rather that be the case. So,
yeah, I was thinking option B doesn't sound much better than option A.
Option C, I think, is the one.
Yeah.
So tell us, Ethan, which of those three outcomes that you've outlined, which one is correct?
Then in the 90s, the observational data came in, and we said the universe, as we observe it, is doing none of these. It looked like the Goldilocks case for about the first 7 or 8 billion years of cosmic history, and then all of a sudden, it was like the expansion started speeding up again. This was a big mystery and a big puzzle, and today, we haven't solved the puzzle, we just have a name for it. We call this the effects of dark energy. That dark energy is some mysterious form of energy present, even inherent to empty space itself, all throughout the universe, that causes the expansion of the universe to speed up, which means if you were watching a distant galaxy, and you were watching how it moves away from you, you would have seen for the first 7 or 8 billion years that it was moving away from us, but it was slowing down and slowing down and slowing down. And then about 6 billion years ago, it started speeding up again and now gets faster and faster and faster as it moves away from us. We still don't know the nature of dark energy. So if this is something that sounds appealing to you, you should know that you can study dark energy both from a theoretical and an observational perspective, and this is an active career that you can have as an astronomer, astrophysicist, or cosmologist today.
Well, Michael, I think it's fair to say that not only have we started season 8 with a bang, but that we've chosen possibly one of the biggest mysteries in the entire universe. I feel like we've kind of like opened up a box, and within that box there are many other
mysteries
boxes.
Within mysteries within mysteries.
So Ethan was talking about dark energy. And this is quite interesting how some of the mysteries we've looked at in other episodes of Mysteries of Science start to link together. So if you remember Catherine Hamans and Sabine Hossenfelder, last season 7, they were speaking to us about dark energy, weren't they? In our Your Mysteries, right at the end of season 7. So, you know, if you're interested in hearing a little bit more about this mysterious thing, which we don't know all that much about, it's there for you. You can go back and listen to it.
I think I know what dark energy is.
Yeah.
Pigeon poo.
You and your pigeon poo.
Yeah. Right, I think it's time we break out the mysteriometer.
I agree. And for any new listeners, or just a reminder for listeners from our last season, this is our high-tech device, which measures how much we've solved the mystery.
Yeah, so it's a scale from 0 to 100, with 0 being we know nothing at all, and 100 is we know everything, case closed. So yes. I wonder where Ethan and Maggie would say we are on that scale when it comes to the Big Bang.
As far as the Big Bang itself goes, I would say we're up at about a 98 there. We have almost everything we could want to know about it. We have the expanding universe, we have the leftover glow, this cosmic microwave background, we have the abundance of the light elements, we have the evolution of galaxies and large-scale structure in the universe.
I would say that we pretty much don't know anything at all. And I feel like the more that we learn, the less we know about stuff, especially for me. I think there's been multiple stages in my career where I felt like, oh, I know this. I'm so smart. But then you learn something new and you're like, oh, okay. So we don't know about this. We don't know about that. We don't know about this. Even simple things as the amount of dark matter and dark energy in our universe.
Wow, I don't think I expected that. We've got 2 ends of the scale there. I'm not sure that we can split the difference and say we know sort of half either, because I think both Ethan and Maggie were making completely different points there. So Ethan's saying there's quite a lot that we know about the Big Bang, and there's lots of evidence that proves it's happening, but Maggie pointed out that there's still so many mysteries out there to be discovered.
Yeah, it just goes to show what a big mind-bending mystery the Big Bang is. But I think we should try, Dan, to attempt to recap what we've learnt in this episode
Gather
about the Big Bang.
Gather our thoughts together. So, right, how do we tackle this? What have we learnt?
So I guess firstly that the Big Bang wasn't a bang like a it was more of a gradual expansion, more of a...
Lovely. Yeah. So, and there are 3 main bits of evidence for it that we talked about that our experts helped us discover. There is the expansion, the fact that everything seems to be flying apart in the universe.
Yes, and if everything is flying apart like that, then by sort of logical deduction, Sherlock Holmes detective style, it must have all started from the same point.
And for such a massive explosion of energy, then there's going to be some kind of leftovers, there's going to be some kind of remnants that we can still detect in the sky.
Yes, and once they realised that it wasn't pigeon poo, they were able to detect these signals out there in the sky, in space, in the universe.
Fantastic. And then lastly, it's the abundance of the elements. Can you explain that at all?
Yes, so Ethan was telling us how Fred Hoyle didn't believe in the Big Bang because he was talking about these heavier elements. What was he talking about? Carbon, nitrogen, oxygen. You may have seen them at school in the periodic table. And Fred Hoyle was saying there's no way these elements could have come from the Big Bang. He was right about that. He said they came from stars instead. So he was correct, but he was wrong as well because the Big Bang did happen. He was just right that it's not where those elements, those things came from.
Fantastic. Well, I mean, I don't think we have got maybe some way towards understanding this mystery, but it seems like also there's plenty more to discover, and who knows, one of you may be the person or part of the team, because I like collaboration.
Yeah, science is all about collaboration, so we'd love to hear from you. If you'd like to send us a voice note and have your voice appear on the podcast, then just head to funkidslive.com/mysteries and hit the big red button.
And you could also get in touch with us by emailing hello@science-nature.co.uk or leaving us a review on Apple Podcasts.
And don't forget to join us in 2 weeks' time for our next mystery. Well, Dan, I can tell you without even needing to speak.
Can you guess what it is? It is. Yeah, right. We'll be sending messages into your brain directly without even needing to talk, because we'll be exploring whether humans will have or will ever have the power of telepathy.
They don't even need to listen to download the podcast. It will just go straight into your brains.
Beaming direct.
No, do listen to the podcast. Until then, stay curious.